Jai Hind, myself Dr. Ajay Pratap Singh, and I am working as a associate professor in Department of Mechanical Engineering and at Ajay Ghaziabad, and teach here the theory of machine for the BTech third year. And today I will discuss basically the acceleration of the linkage, how to calculate the acceleration if the any link of or any mechanism that the one point of the mechanism, one point, the magnitude and direction of the magnitude and acceleration of given, direction of the acceleration is given, and the other point that the only direction will be given. So how to calculate the acceleration? So in the previous lectures I have discussed the relative velocity method to calculate the velocity. In this regards, that's the continuation of this. We can see if we draw the acceleration diagram for the any mechanism, velocity diagram is the mandatory for that, because for any velocity diagram, first of all we calculate the, we can say the magnitude of each linkage and draw the magnitude and find out to measure basically through, and the actual value will come after that. Because in this acceleration diagram, that the divided into two categories, we will discuss in the one is the radial and the tangential. So radial, when we will draw the acceleration, so that radial component is always known due to the velocity diagram. So I have discussed the velocity diagram in the previous lecture. So in continuation of this, I will continue to the acceleration diagram. So consider for the drawing, draw any you can say that acceleration diagram for the link. So consider a 2 point A and B on a rigid link, and let the point of B moves with respect to A, right. So point B with respect to A, it moves with an angular velocity omega radian per second, and let the alpha, the angular acceleration, the alpha radian per second square to be the link of AB, and alpha is known as the angular acceleration. So the acceleration of the particular particle whose velocity change both magnitude and direction at any state of the following two component. One is the centripetal or the radial component, which the perpendicular to the velocity of the particle at the given instant, and second one is the tangential component, which is the parallel to the velocity of the particle at the given instant. So you can see here that this is the one link, right? This is the one link, and in this link you can see here that the one link is the one body, that in this case that is the point A and the B, right? A and B, and the point A, let the point B moves with respect to A, and the angular velocity alpha, so sorry, the angular velocity, that the omega radian per second, the link is rotate, and let the angular acceleration, that alpha is also in the rotate in anti-clockwise direction. So the acceleration of any body, we can say for the particles whose the velocity change both and magnitude and direction at any instant. So we have two basically the component divided into two component. One is the radial component and second one is the tangential component. So the radial component of which perpendicular to the velocity of the particle at the given instant, and the tangential component, we can say that is which the parallel to the velocity of the particles at the given instant. There are two things. So we represent from the radial component, that is if suppose a radial component we represent A, acceleration A, R, B with respect to A, and second one is tangential A, T, tangential component B with respect to A, right. So the radial component B with respect to A is, we can say that is perpendicular to the link AB, and tangential component is parallel to the velocity of particular point, parallel to velocity of B with respect to A, right. So there are two things. One, always remember that the two component will generate. One is the radial component. The radial component is perpendicular to the link of the AB, and the second one is the tangential component. The tangential component that the parallel to the velocity of B with respect to A. Right. So we draw how to draw this how to draw the velocity diagram, how to draw the acceleration diagram of this particular link, right? So we will go to step by step. The link AB, the velocity of B with respect to A is perpendicular to link AB, and since the point B with respect moves with respect to A, the angular velocity of omega radian per second, and this force is the centripetal or radial component of B with respect to A. So omega r, we can say that the omega AR BA equal to omega square into length of AB, right? So we can say that AR BA radial component equal to omega square into length of link AB, that is the, and we can represent omega equal to, already discussed, omega equal to VB, velocity of B upon AB, we know, right? So we can write omega square into AB, that we can write that is the velocity square B with respect to A divided by AB, and this radial component of acceleration acts as the perpendicular to this link AB. Sorry, these radial component is perpendicular to the velocity of B with respect to A, or we can say that is parallel to this link AB, right? The radial component of acts as the perpendicular. The radial component, it acts as a perpendicular to link velocity of B with respect to A, or we can say that the parallel to link AB, right? Second, the tangential component of the acceleration of B with respect to A is known as, represented as ATBA, that's alpha into length of link AB, or we can say alpha into AB. So the tangential component of the acceleration acts at the velocity of equal to the velocity of B, the tangential component of acceleration acts as the parallel to the velocity of BA, or we can say that the acts as a perpendicular to link AB. So there are two things, one is the tangential component, one is the radial component. The tangential component is perpendicular to AB, perpendicular to link AB, or we can say that is parallel to the velocity of B with respect to A. So how to draw the acceleration diagram of any for any link? So we can come to this. In order to draw the acceleration diagram of link AB, you can see that from any point B dash, right? Draw the vector B dash x parallel to link AB. So you can take here that is some point, that is B dash. B dash is the one point, and draw the B dash x is parallel to BA, because that is the radial component, and the radial component of relation of B with respect to A. So we can see here, we can draw that B dash, I will draw in different color. So you can see that I can, right, this point is the x, and these represent, we can see, you can write here that represent acceleration, radial acceleration of B with respect to A, right? From x, and from point X draw the vector x a dash perpendicular to BA that represent the tangential component of acceleration of B with respect to A. So we can draw here that x a dash x a dash some point I think just wait 1 minute. X a dash and x a dash is that is the tangential component of B with respect to A, and after that join B dash and A dash, join the B dash and A dash, join the B dash and A dash. This is known as acceleration of B with respect to A, and it known as the acceleration of image of the link AB, right? Acceleration image of link AB and represent the total acceleration of B with respect to A. That is acceleration of B with respect to A. So it is the vector of some radial component and the tangential component of the acceleration, right? So you can see in this figure or the figure number B, we have first of all the step 1, draw the some suitable point at the in velocity diagram we will take small a b c. In case of the acceleration diagram, a dash b dash, right? So I will taken here that the one point that is b dash, radial component is known, right? The radial acceleration is known because that the omega is already known. Then length of the link is available, so we can calculate and measure and draw b dash to x point, some parallel to this link AB. So we find out parallel to link AB, so radial component will be generated. After that from X we draw the tangential component alpha into length of link AB. So alpha is known, length of the link AB is known, so we can draw the length in the direction of this. So tangential component, the parallel to this link AB or the perpendicular to link AB. So parallel to link velocity of B with respect to A, or we can draw from X perpendicular to link AB. So draw the tangential component because magnitude is already known, because alpha is given and the length of the link is given. After that join the link A dash to B dash and it represents the total acceleration B dash and A dash, that's known as acceleration image of the link BA, right? So you can draw. After that come to this, so acceleration of link of the any point is suppose consider the 2 points A and B. This is the link, the real link, and let the acceleration of point A, that is acceleration A, is known in magnitude and direction, and the direction of path B is only given, not given the magnitude. And in this case the acceleration of the point B is determined in magnitude and direction by drawing the acceleration diagram, right? So we can see here, you can see here that the one link AB, I will draw in the different color so you can understand. So I will draw in the red color. So you can see here that the link AB, right, A and B. So here that the link A and B, this point A and B, the link AB is there, right, and point A, the magnitude and direction is given, right, the magnitude and direction is given, the acceleration of A is known. Point B, only the acceleration, only the direction is given. It means the velocity of B with respect to known, right? So how to draw? From any point O dash, draw the vector O dash A dash parallel to the direction of absolute velocity, sorry, absolute acceleration. So you can see here, from take the some suitable point O dash, take the some suitable point O dash. So I'll take here only that the suitable point O dash, right? O dash, and draw the O dash A dash parallel to the direction of absolute acceleration, that is the acceleration of wave with some suitable scale, so that we can find out these point O2, O2 A dash, and this is known as acceleration of A, right? This is known as acceleration of A. After that, we know that the acceleration of B with respect to A has the two following component. One is radial component and second one is the tangential component. So the radial component of the acceleration of B with respect to A, and second one is the tangential component of B with respect to A. So these two are components are mutually perpendicular. So how to draw? Come to one by one. So you can see in here, in the last slide I have drawn, that is take the some suitable point O dash and that draw the parallel to A dash, that is known as acceleration of A, right? So from A dash X parallel to the link AB, A dash X that is parallel to link AB, there because the radial component of acceleration of B with respect to A will passes through AB such that A dash X equal to ARBA, and ARBA equal to velocity B with respect to A square into AB, and VAB the velocity with respect to A. So from X, draw the vector X B dash perpendicular to the link AX, A dash X, because the tangential component B with respect to A perpendicular radial component, so that the from O dash draw the line parallel to the path of B with represent the absolute acceleration of the B, and that is the acceleration of B. And these vectors X A dash and X B dash, X A dash and O dash B dash intersect at point B dash, and now these value are acceleration of A and acceleration of radial may be measured to the scale. So you can see here basically from A dash, after that come to this, draw the radial component and the tangential component, right, from this B to A. So radial component is that the radial component B with respect to A is parallel to this. So you can draw A dash X, you can see here A dash X is the radial component ARBA, right? After that we can draw the tangential component. The tangential component is perpendicular to link AB. So I draw here in the different color the tangential component. So you can find out here that the tangential component, right? So X B dash is the tangential component ATBA, and now join that O dash to B dash, join O dash B dash and B dash A dash, right? So join O dash and B dash and B dash and A dash, right? So the O dash draw the line parallel to path B to the represent the absolute velocity of the B, that is the absolute velocity, right, acceleration of B. acceleration of B, and the vectors x b dash, the vector x b dash and o dash b dash intersect some points. These points is known as b dash. You have find out. Now the value of acceleration of A and the tangential, you can measure this value, you can find out, you can measure this value, and you can find out this value, right? And this is the actual A dash B dash. You can say that this equation, that the green color I have written in the blue color, these lines represent the blue lines. These lines is known as acceleration of B with respect to A, right? So suppose if you have another three link, that the point C is here in this link, you can see the C link, point C. So A to C and B to C, right? There are two links is there. So in that case, there are two for B to C to A, that the two radial component, and C to B again the two radial component, and C to A the tangential component one. A to C, acceleration of A to C, C to A is the radial component as well as tangential component, and acceleration of C with respect to B again the radial component, tangential component. So we need two extra pole point will taken, that is y dash we can take, that the y taken. So you can see here in this, that draw the radial component from A to X, then the tangential component, here the radial component and tangential component. After it coincide at that point, and that point is known as at the C dash. And you can again draw this X to B dash to C dash and C dash to A dash. So these is represent, basically you can say that the acceleration image or the acceleration of B with respect to A calculated, right? So these are the basic things in the I think the acceleration of point of the link. And the joining of, you can see the joining of I'll discuss in the previous, that the will taken the 2 points, extra point at the x y dash and z dash, right? So A dash to x y dash is the radial component, and y to c dash is the tangential component. Then B to Z dash is the radial component, and C to Z to C dash at intersect this point, right? So by joining of A dash and B, we can measure the total acceleration. From any point of C, we can say that the link, draw the triangle A dash, B dash and C dash, and similar triangle ABC. Now we can say that the vector of B dash, C dash represent the acceleration of C with respect to B. That is acceleration of CB, and the vector A dash C dash perpendicular represent the acceleration of C with respect to A, that is CA. And I discuss in the above, we can say that the acceleration of CB and acceleration of CA will each have the two components. One is acceleration of C with respect to B, acceleration of C with respect to B. There are two ARCB and tangential component ATCB. And acceleration of this one have the two component. One is ATCA and ARCA. They are two component, right? So these component A to CB, you can see in this figure. In the figure B, acceleration of C with respect to B has the two component, radial component, tangential component. So you can see here B dash to Z is the radial component, and Z dash to C dash, right, the tangential component. And the triangle, you can say B dash, Z dash, C dash, which is B dash Z is parallel to BC, and the C dash is perpendicular to length B dash Z, or we can say the BC. So you can draw this and find out the measure of all the values, and we can say that for any link is extra link will given, so you can calculate in the same ratio and find out that, right? So please remember, if I summarize here, basically you can see if any particular point has the acceleration and magnitude and direction given, another point is the only direction will given. So we can draw the velocity diagram and you can find out the acceleration and acceleration link image of this particular link. And other point, in any case the given the other two links, so we can again draw the radial and tangential component, and after that we can intersect at some suitable point and we can calculate them, right. So I hope you understand this the acceleration of linkage. Now in the further, in the next lecture I will discuss basically the slider crank, how to draw the acceleration of slider crank mechanism, and one numerical will discuss, and then you can understand the basics. So thank you so much, and if you need any help, please feel free to contact with us.